Welcome to Tech-Oasis YouTube channel. Today we are going to discussing about the giants concept in the Pyspark. So first of all, we have to know about what is giant. See, giant is nothing but it is an operations which can be used for combine the rows from two or more tables or two or more data sets based on a rated column between two of them. Okay, it is a commonly used in a database and data processing frameworks like Spark to retrieve the data from multiple data sets. It is distributed across multiple resources. If you talk about majorly the key concepts is like giants match record in one data sets with records in another data sets based on a common values. Usually we can call it as a like here a column name. Okay. For example, if we have a customer table and an orders tables, we are going to we could join them on the based on customer ID, to get all the records placed by each customers. Okay. So like we can make some points like so what is join? So a join is nothing but a operation. Sorry, it can be used for combine the rows from two data sets or two data frames based on the related column key or like a column name or column values. Okay, so a join is nothing but operations and which can be used for combine the rows from two data sets or two data frames. Okay, but we are going to fetching based on the data based on the key column. Okay, that's it. First of all, we can going to see that syntax of the join here. So first of all, how the join syntax will exist. Like a syntax is nothing but how will join will going to action. Okay, so syntax of the join is like if you see like this is one data frame, here two data frames like df1 and df2. So df1 dot join df2, okay, based on the join column. So which column we are going to taking in between the two data sets. Okay, that is the this is the like a common column name which is existing in the both data sets. And comma in double quotes only we have to mention like join type. Either we are going to perform like a inner join, left outer join, right join, full join, or any join. We have to mention the join type as well here. So now again once look here, df dot join df2 comma in double quotes we have to mention the common join column along with comma in the double quotes again we have to mention the join type. Okay, this is the syntax of the join. So then after that we are going to see the join executions. Okay, how the join actually will going to executing inner side. Okay, basically in the PySpark performs the joins by comparing the values in the common key column between the two data sets. So as like in the definition of the join only as we discussed, right? So based on the common key column, okay, based on the key column only it will going to perform the join, otherwise it can't it will not possible. So based on the common key values only we are going to performing the join operations. Okay, then after that we are going to look on it the types of joins. Okay, see here basically if you talk about the major types what are the like this in the joins like in the joins like inner join, left join, right join, full outer join, and left semi join and left under join. See in the left join only we can call it as a left outer or left join or left like in the right join we can call it as a right outer join or the full outer join. Okay, if you talk about major the right inner join, see inner join actually it returns only the matching rows. Okay, with matching keys in both data frames. Okay, if you talk about generally, inner join actually basically it retrieves the data which are exist in the both data sets. Okay, see the data must and should be it exists in the data frame 1 and data frame 2. Then only it retrieves the data. Otherwise, it will not perform the inner join. So the inner join is its definition is something but like it retrieves the data which are exist in the both data frames. Okay, the rows which are matching in both data frame, then only it will returns. If the unmatched records are, it will not return. Okay, it will just explicit it. Okay, and then after that if you talk about left gen is nothing but it returns all the rows, all the matching rows from the left data frame. Okay, and then matching rows from the right table. See here it will fetch all the matching records from the left table along with matching records from the right table. Then what about the unmatched records here? So the unmatched records are we are getting as nulls here. Okay, unmatched records getting as nulls. Okay, see if you see here returns all rows from the left table and matching rows from the right data frame. Unmatched records are getting as nulls here. Okay, this is the majorly syntax of the left gen. If you talk about the right gen here, similarly is also like as same like it's quite opposite to the left gen. Okay, in the right gen it will returns the all rows from the right data frame and matching rows from the left data frame. Okay, majorly if you talk like it retrieves the all records from the right table and matching records from the left table, but unmatched records are similarly here also we are getting as nulls. This is the syntax of, I mean, this is the definition of the right gen. If you talk about the full outer gen, it is a combination nothing but a two gens, left and right outer gen. I mean, left and right gens. Okay. we can mention in bracket like similarly. It is a combination left plus right join. Okay, it returns all the rows from the both data frames. Okay, it will return the all rows from the both data frames, including the matching and non-matching rows. See, if the record is matching, we are getting the value. If the record is not matching, then it will come as a null. That's the thing only here. Okay, if you see about the left semi join is nothing but it returns the all rows from the left data frame where there is a match in the right data frame. Okay, it will give only the matching ones only in the where, but in the right data frame it will give the rest of the, it will see, it is quite opposite to inner join. Okay, I mean left join, it will returns the all rows from the left data frame where there is a match in the right data frame only. Okay, and left anti join is, it's quite opposite to left semi join. See here the definition, return all rows from the left data frame. Okay, where there is a no match in the right data frame. If you observe here left semi join, where there is a match in the right data frame, then only it will give the records. But in the left hand design, where there is no match, okay, where there is the no match in the right data frame, then only I mean such type of records only it will give output. Okay, this is the major difference. Okay, now we see the practical sessions like we had created two data sets, and we are going to performing some like the joint conditions. We see a real-time example, like a small kind of example. We're going to just look at it. Let me open my database community edition. Just a minute. Actually, I had created Spark community edition, and I had created my cluster as well here. Let me increase my font size. Yeah, I hope some better. Yes, sorry for this. Yeah, now I had, now observe the code here. Just I'm importing few libraries like Spark session, and I'm just spark.sql functions import star. In the sense, it will going to import all libraries which are exist in this. Now just I'm going to creating two data frames. One is the customer data frame, another one is the order data frame. Okay. Now by using the struct type, and I'm just defining the schema, and we are going to inserting these are all values, and I'm just creating one data frame here. Then after I'm making two data frames, then after just I'm executing here. So just I look at data frame once here, what values did I paste here. If you see here, this is the customer data frame, this is the order data frame. But try to observe here, in the customer data frame we have three columns. One is customer ID, and another one is name, another one is country. Okay, in the orders data frame also we have three columns. One is order ID, one is customer ID, one is product ID. If you observe here, in the both data frames we have one common key column, that is the customer ID. Okay, so now we are going to performing these are all joins based on the one common key, I mean common column value, that is only customer ID. Okay, so based on the customer ID we are going to performing the joins conditions now. Okay, let me perform the inner join first of all. I am going to perform in the inner join here. See, customer df, I mean this is my customer table, customer df dot join order df. I am going to joining the orders table. Okay, based on which customer ID column, customer, this is the column name. Okay, based on customer ID column I am going to performing this, and which type of join I am going to performing here, inner join. So did you see the syntax in the earlier as like this only? So here if you observe inner join customer, I mean inner join df is equal to customer df dot join order df. Here the customer data frame will going to join with order data frame based on the customer ID column. I am going to performing the inner join here. Okay, now we'll execute this once. We can able to see the output here. Just we observe here. See, we observe here, we get only three records. So we have only three records which are matching in the both customers and order data frames. So just now we are going to look on it actually. What are those three records? If you observe here in the customer ID we are having the four records, that is 1, 2, 3, 4. In the orders data frame we have seen customer ID we are having four records, that is 1, 2, 1, 5. See here, one is having in the customer ID 1, that is having two times in the orders data frame here and here. So here only we are getting the two records. Okay, coming to second, that is 2. 2 is also exist in the order data frame here. Okay, now 2 plus 1 3. Okay, let's come to here 3 exist. Okay, 3 is here exist anywhere in the orders data frame? No, it will not exist. Coming to 4, 4 as well it will not exist. So what is the inner join condition here? It will reduce the matching records only bit in both data sets. Okay, see, one is having, okay, one here also having, here also having, coming here next one 2, 2 is having, here also having, here also it's having. So if you count total 3 records only we are getting. See, we are getting only 3 records. Okay, now talk about the left join. Okay, just we execute once here. What is the left join syntax? It will records the, I mean it will fetch the all the matching records from the left table along with matching records from the right table. The rest of the things will going to come as a nulls here. Okay, now observe here, total how many rows we got it? 5 rows, 5 records we are going to got it based on that condition. Okay, If you observe here, what are the records for coming like customer ID 1, 1, 2, 3, 4. Okay. Now coming to this, see here. Now we are going to do the left gen, right? So all the matching records from the left gen. Okay, matching records. What are all we have? One is having, I mean, one, two. These are all the matching records. Okay, two rows ordered will come. All the records in the sense four will come. Okay, the matching records are how many is there? Only two is there. Now come here. See, one, one. The rest of the two. So total five records. So all the matching records from the left table plus matching records from the right table. This is the definition. So based on that only we are getting this. Okay. And similarly right gen as well. It is right gen is quite opposite to the left gen. Okay. It will fetch the all the records from the right table, the matching records from the left table. Okay. Similarly, it will also will going to work. Full outer gen. Full outer gen is nothing but it is a combination of the left gen along with the right gen. Okay. What it will give? It will returns the all matching plus unmatched records are we are getting as here. Matching records we are getting as usual the existing value. The unmatched one we are getting as a null here. If you observe here, this is the null, this is the null value, this is the null value, this is the null. So like that. So what is the definitions here? Full outer gen. It will returns the all the records which are matching and unmatching. Matching one we are getting as usual values, and the unmatched one we are getting as the null values. Okay. Yeah. Now coming to left semigen. Yeah. Here also, if you observe here, we are getting only the two, only two records only we are getting here. Okay. Now just once observe here the definition actually. Left semigen, what does it mean? If you see this, the left semigen returns all rows from the left data frame. But when it will give where there is a match in the right data frame, okay, it will returns the all rows from the left data frame where there is a match in the right data frame. Okay, it is so this is the left semigen. Now just look on the result. How will going to actioning here? See, it will having the only two records. Coming to the next one, that is left antigen. It is very quite opposite to the left antigen. It is both are, I mean, the left semigen is quite opposite to the left antigen. So this is a major differences. And one more is there, that is the cross gen actually. Cross gen is nothing but m into n. I mean like where there is n number of columns are will going to multiplying with the other data frame. One data frame columns are multiplying with the another data frame. Now, for example, as per our example, customer data frame values will going to multiplying with the orders data frame. Now we observe here total how many records will come. See total 1, 2, 3, 4. Just apart from that, just we count here only. See if we observe here in both data frame we are having how many records? 4. Here also having 4. So m into n, 4 into 4. Total 16 records will come here. Just go and observe here just once. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. See, total 16 figures will going to fetching here. So Cartesian is giant nothing but it will give the output as m into n format. Okay. So this is the like a basic understanding concept of the giants which in Pyspark wise. The definition will going to same as usual in SQL also. So yeah, thank you. Thanks for watching.